Okay, this is the first lecture for our next chapter, chapter 9. You'll be viewing this probably once you get back from Easter break. Hope you had a great Easter break. I'm recording this in the future, so I have no idea what's going to happen, because if I did, I would have already won the lottery and I wouldn't be standing here talking to you. I'd love you still, but I wouldn't be talking to you. Okay. Circles and circumference are the first section. This chapter is about circles. Okay? As I've said before, if you understand circles and triangles, you've got the lowdown on geometry. Okay? Your resources for this: the first 6 pages of your notes. Okay? And then the PowerPoint for chapter 9, section 1. Okay? Things we're going to go over, gotta have an idea. A circle. The definition of a circle: the set of coplanar points equidistant from one common point. That's called the center. The biggest word in this sentence and definition is coplanar. Okay? Because that locks it onto a flat surface. That's why it's a circle. If we remove that one word, okay, just a set of points, now we've got a sphere. Okay? In a sphere, you've got 3 dimensions. You have depth, you have volume, things we will get into later. Okay? So that's the set of all points. Okay? When you see a circle with a dot and a letter, that is how we symbolize circles. Circle with center at point M. Okay? Terms we're going to have to deal with, and I'll get into in a second. Okay? These right here. We need to know what a circumference is. A circumference is the distance around a circle. Circumference is to circle as perimeter is to polygon. Notice the alliteration. Circumference, circle, perimeter, polygon. Yeah, I'll clean the stuff off the screen in a bit. Okay? That's it. The ratio of the circumference to the diameter, that is pi. Also a lovely fruit dessert, not to be confused with tarts or cakes. No, pi. The Greek symbol pi. Okay? So if the circumference of a circle equals pi times the diameter, that means the circumference divided by the diameter is equal to pi. And it will for every circle. So the distance around a circle divided by its diameter is pi. It's a ratio. Ooh, there's that word again, ratios. Okay? A couple other terms. Inscribed, inside. That means a polygon is inscribed in a circle if each vertex is on the circle. And then circumscribed, okay, drawn outside. That's when each of the sides of the polygon are tangent to the circle. Okay? Important distinction. We will see some later. Now, let's go over some terms. Okay? These are the terms we have to know. And yeah, okay, I wouldn't try writing these down now, because obviously I'm going to take a picture of it and provide that to you. So keep that in mind. Okay? Yes, I've color-coded. Yes, I'm that wackadoodle. Okay? So here we go. The radius of a circle. In this one, XA is one of the radii. Radii is plural. One radius, 2 radii. Okay? It's the distance from the center to a point on the circle. For radii, I want you to think of the spokes in a bicycle tire. They're all the same length. That's why you have a smooth ride. If they were different lengths, you'd be riding like this, and it's not fun. Trust me. Okay? A diameter, in this one, DH or HD, is a segment, okay, that contains the center of the circle. It's the longest chord, okay? It contains the center. Has to have the center. Okay? There's that word chord. Chord is just a segment that begins and ends, the end points are on the circle. Okay, think about it for a second. When we're looking at circles, we have the interior of a circle, we have on the circle, and we have exterior, everything outside. Okay? A secant, okay? Secant is a line that cuts through, intersects a circle at 2 points. Okay? A secant contains a chord. That's a chord. But if we're looking at the whole thing, it's the secant. Okay? And a tangent. We used that before. The tangent never goes into the interior of a circle. It touches the circle. It's tangent to the circle. Circles can be tangent to each other. Okay? Think about a snowman. Okay? You'll see some of those on the notes, okay, for this particular section. Okay? Circles can be tangent to each other, either inside each other or outside touching. Okay? Now, if you think about a tire, the circle, and the road, the tangent, that's how it kind of works. Okay? Never goes inside, it touches. Okay? So these are the terms you're going to deal with. Okay? So let's move over to some examples. Okay. First one here, all of these go to this particular circle right up here. Okay? So we want to name the circle. Okay. L is the center point. So we make a circle with a dot and that point. Okay? A radius. There's one, there's one, there's one. There's 3 drawn in this particular circle. Each of those are circles, or radii in the circle, excuse me. Okay, a chord. You've got ST, SR, or don't forget the diameter, RT. Okay? Okay? Which leads us to the next one. Name a diameter. RT or TR. Same thing. Name a radius not drawn as part of the diameter. Okay. So as the diameter, we've got LT and LR. That means this one, we've already named it. Okay. We just name it again. Okay. Now, if the radius of the circle is 3.5, what's the diameter? Diameter consists of 2 radii. So 2 times the length of a radius is the diameter. 2 times 3.5 is 7. Okay? If RT is 19, RT is the diameter. Okay? It's the diameter. LW is a radius. And we've learned that each radii in the circle has the same length. Okay? So if that is 19, this is 9.5, that's 9.5, that's 9.5. Okay? So that's labeling and just some basic concepts there. Now this one, okay, we've got 2 circles, okay, and they're overlapping. There's some intersections there. The diameter of circle L is 20. Okay. The diameter of circle M is 13. Okay. QR is 4. Okay. Here we go. Find L to Q. Okay, if LP, okay, the diameter is 20, so what's each radius? 10 and 10. Okay? And over here, if that's 13, okay, we're going to have 6 1/2, 6 1/2. Okay? So, what have we got? Well, if L to P and L to R, each of them is 10, 10 minus 4 is 6. Okay? 10 minus 4 gives me 6. Okay? RM, that distance right there. Okay, if that entire distance is 6 1/2, and I subtract that 4, okay, just about relationships. We can deal with each of those. Okay? Now, find the diameter and radius of a circle with the given circumference. Round to the nearest hundredth. Okay? You're going to get two different types. Okay? We go back to what we talked about with square roots. There's a difference between exact and approximate. This is asking for approximate because it says to round, and we're going to use 3.14 for pi. Okay. Easiest thing to do is start with your formula. Okay. Okay. So, we know the circumference is 21.2. Divide using your calculator, okay? Yeah, I gotta put on the glasses to see my own writing, okay? Okay, so there's your diameter. Okay, we know the diameter is 2 times the radius. We know the diameter. Okay, so here's our answers. Now, if your question asks or tells you to leave it in exact form, that means we leave pi in the answer. Okay? So in this case, if we were finding the circumference and we knew the radius, we would just leave pi as part of our answer. Perfectly acceptable and the way to do things. Okay, here we go. We've got a circumference of 5.9. We're going to do the same concept here. There's our setup. Now we're just going to divide, nothing more. So there's our diameter. Now we do the same thing. We divide it in half. There's that answer. Okay? Now, our last two questions, okay, have triangles. Okay, now here's what it says. Find the exact circumference of each circle using the inscribed polygon. Okay, all on the circle. Well, since we have a right triangle, we're going to use the Pythagorean theorem. Okay? The diameter of this circle is the hypotenuse. Okay? So we'll just say D. And that's what it's going to be. You can remember that a 7, 24, 25 is a right triangle, or you can do the Pythagorean theorem. Okay. So we know that the diameter is 25. We know the circumference is pi times the diameter. Okay. That's the exact circumference of that circle. We do the same thing here. Okay, 40, 42. Once again, diameter is, okay, so we're going to go here, 40 squared plus 42 squared. We got a pen that's running out of ink. Okay, so what we're going to do is square those all out, and then you're going to find some very, very large number. And then you're going to hit the square root key, and look what you're going to find. $58 is equal to D. Okay? That's the last problem for that pen. Okay, so 58 is the diameter, the circumference equals 58 pi. Not a difficult section. Make sure you get your terms and you're understanding where they are in the circle, because they're going to have different relationships with things. Okay, especially once they start forming angles. Okay? Okay.